The second part of the homework for this week is called My First Homework for 300 Part 2, and it has a separate due date. It's due a few days after the first part, and check on D2L to see what the exact due date is. There's three problems here. One of them is all same, we have num unique, and then we have remove duplicates. So we'll walk through these one at a time. And the first of these is all same. The idea here is we're going to return a Boolean result. So that means we'll either return true or false based on whether all of the elements of the array that we're looking at are the same. So you can see here some indications of what it should do. So if all the elements are the same, so they're all 11 in this case, then we should return true. If there's only a single element, well, obviously they're all the same. Likewise, for the empty array, so if there's no elements at all, we should return true. So note that this should work for the empty array as well. And we're just going to define that to be true. So if there's no elements, then they're all the same. But there's also cases where it might be different. So we might have an element that's different here at the end. We might have a different element, in the middle. And obviously the value 11 is not special. It could be anything. So let's think about how we'd solve this. If you say we've already looked at the first two elements and we're about to look at the third one, well, what do we need to know up to that point about the past? Well, at this point, what we need to know is whether or not we've seen any different element than the previous one we saw. So, in other words, if the previous element is 11, then we need to assume that they're all 11s before that, or that something at some point was different, and we can manifest that sort of in a Boolean variable, which tells us whether or not we've seen something different. And here I'll just leave that blank for now. But the idea here is that we could have a Boolean variable and then return it at the end. So this is going to be my accumulated value, which sort of tells me, have I seen anything different so far? So at this point, if we're looking at at this where I've already seen two elements, then I would expect this to be true at this point. And now what I need to do to make a step of progress is just look at this element and see if it's new or not, or is it the same as the one I just saw. And if it's the same, which it is in this case, then I can just move on. Right? So I would move on to the next element. And at this point, I'd see, oh, that's actually now not the same as the previous element, so the value is different. And so you can see here what I've got is some sort of coding like this, where I'm going to have a loop of some sort. And in the body of the loop, what I need to do is to check some condition, and then to look to see if that condition holds. Then I'll set the result to false. And so something like this should work, and this can be a one-armed condition. So note that I don't need to have a else branch here, because if I see something new, I want to obviously set this to false. But let's suppose I have previously seen something out of whack with the past. Well, then I want to leave that alone, regardless of whether or not I see something that's the same. So even if at this point, if I had seen a 22, well, I don't want to go back and change this. So I don't want this to be an if-else. I just want it to be a single-armed sort of if. Okay, so anyway, this is the idea of all same. To introduce the next two, I'll go back to my prior self. So these are homeworks I've been giving for a while. So I'll go back to former me to introduce num unique and remove duplicates. Let's look here at num unique. There's its Java doc. So num unique is going to return the number of unique elements in an array. And really what I'm talking about is adjacent elements. So what we're going to do is we're going to assume that the array is sorted. Okay, so the array will always be giving you the numbers in increasing order. So to tell if there's duplicates, it's sufficient to just look at adjacent elements. And that's important here because we're only allowed to use one loop. You're not allowed to use any recursive calls, not allowed to call any other functions, only one loop. And so what we need to do is go through and see how many different adjacent elements we have. All right. So in this case, we're also allowing the empty array. So we have to deal with that. And what do we do for the empty array? Well, obviously it has no elements, so there's no unique elements. For a singleton array, it's always going to be 1. So we only need to worry about arrays of size 2 or greater. We actually need to compute something. So starting with the second element here, you can see, well, it's the same as the first, and in fact, they're all the same. So this is still size 1. Here's a more complex example. So this function's a little more difficult to write, so let's think about how you might write it. Let's suppose you follow the methodology that I gave you in the previous lecture, which is we'll start in the middle. So let's suppose we start with this element. So what do we need to have computed before we get here? Well, by the time we get to this element, we should know that there were 4 unique elements before me. And those were 11, 22, 33, and 44. So I need to have already seen that there were 4 unique elements. And now what I'm doing when I look at this element is to say, well, now is this one new or not? If it is new, then I need to increase the number of unique elements. Otherwise, I don't. So if this is new, is it? No, it's not. It's the same as the previous one. So I don't need to do anything. I go on to the next element. The same as the previous one. Go on to the next element. Same as the previous one. Only when I get to 55 do I see something that's, oh, it's different from something that I saw before. So it's different from the previous one. Again, we're assuming it's sorted, so you really only need to look at the previous element. Okay, so there's an inductive solution to the problem. Now you just need to figure out the beginning and the end and put that all together. Or if you follow my methodology, do the end and then the beginning, right? So we always start in the middle, then the end, then the beginning, then the corner cases. Okay, the next function is called remove duplicates. Remove duplicates is meant to return a new array. So what I'm going to do is create a new result array and return it. So what are you supposed to do? Well, you create a result array of the right size, you return it. By the way, I put it to do here, but you can type anywhere in this function. I mean, if you want to do something up here, that's fine. But you shouldn't change the signature of the function, though. That's the important thing. This line needs to be the same. All right, so what does remove duplicates do? It's not really removing the duplicates. It's actually copying them into a new array. So one difference between arrays in Java and lists in Python is that arrays in Java have a fixed size. So once you've created an array, you cannot change how many elements it contains. So that means that for this problem, we need to determine in advance how many unique elements there are. And well, conveniently, that's what numUnique does. So using numUnique, we get the number of unique elements. Then we create an array of doubles with that size. In Java, arrays are always initialized to 0. So what we need to do after we create the array is to put the correct values in. We don't want to just return zeros. So what are we going to do? Well, this is another loop you need to write. So again, should be one loop here to go through and put the correct values in. If you get numUnique correct, the structure here for remove duplicates is very similar. Okay, so that's the homework. Good luck.